Continuing our work with functions, which we started in the 2.1 notes, today we're going to talk more specifically about function notation, which is just a way that a function can be written in order to find specific output values for given inputs. So what we're used to seeing for equations, or functions in general, is xy notation, which for example would look like this: y equals 2x plus 3. And that's in sort of an xy notation where we're using two variables to show an equation where x is the input value. We plug it in here, evaluate this expression, and get our output value for y. The same equation can be written as a function in function notation, and it would look like this: f of x, which just reads as a function of x, equals 2x plus 3. So essentially, you're just replacing y, your second variable, with this f of x notation, which just reads a function of x. So it really doesn't change anything about the equation or the function in general. It just changes the way you write it. And the way this is set up is your input value goes here. So whatever number you see in the parentheses here, you would plug in for x and evaluate the function at that input value. So let's try some examples. So it says, given the functions f of x equals 4x plus 10 and g of x equals x squared plus 3x plus 2, find each value. So this first one says f of 3. And so what that means, if f of x equals 4x plus 10, f of 3 would equal 4, and instead of x we're going to write 3 plus 10. So all we're doing is replacing the x with the input value given in the function notation. And now we just evaluate the function. So 4 times 3 is 12 plus 10, and 12 plus 10 is 22. So the function here, f of 3, equals 22. Let's go to the next one. G of negative 3. So we're using the g function, which is x squared plus 3x plus 2, and we're evaluating the function at negative 3. So we're going to plug in negative 3 for every x we see. So negative 3 squared plus 3 times negative 3 plus 2. And now we can just go through and evaluate those operations. So negative 3 squared is positive 9. 3 times negative 3 is negative 9. And we still have plus 2. Well, 9 minus 9 is 0, so 0 plus 2 is 2. So g of negative 3 equals positive 2. So we evaluated the g function here at negative 3, and we got 2 for our output value. All right, this next one says f of 2y. So instead of x, we're just going to write 2y. We're using the f function, which is 4x plus 10. And the input is 2y. So we have 4. Instead of x, we'll write 2y plus 10. Now we have to simplify. Because we have a variable in our input, we're going to have a variable in our output because we don't know the value of that variable. So 4 times 2y is 8y plus 10. And we can't do anything else here. This is as simple as this can get. So f, the function at 2y, equals 8y plus 10. And so 8y plus 10 is the solution here, and it is the function at 2y. Let's do some more examples. Here we have the functions f of x equals 4x plus 10. Oh, same two functions, 4x plus 10, and g of x equals x squared plus 3x plus 2. Same two functions, find each value. So here we have 2 times g of a. So a is our input value. We're putting it into the g function and multiplying it all by 2. So to write this down, we'd have 2 in our brackets. And we're going to plug a in for every x we see. So that's a squared plus 3a plus 2, right? Because we're using the g function. And so all we need to do here is multiply this by 2. So that's 2a squared plus 6a plus 4, and that's it. That's as simple as we can get that. So 2 times the g of a function equals 2a squared plus 6a plus 4. Now let's look at e. We're using the f of x again, f of x function, because this f here, so f of x, and we're inputting 2 minus x instead of x. So we're replacing all the x's in the equation here with 2 minus x. So our f function is 4x plus 10, so that's 4 times 2 minus x plus 10, just like that. And now we just evaluate, right? Distribute the 4. So 8 minus 4x plus 10. Let's go ahead and rewrite that so it's in better notation. So the negative 4x should come first, and then 8 plus 10 we can combine. So negative 4x plus 18. And there is your solution for this one. F of 2 minus x, which you can write again if you like, equals negative 4x plus 18. Okay, last one here, we have negative 4 times g of x. So the input actually isn't changing. The input here is x, just like it is here. We're just multiplying the whole thing by negative 4. So that's negative 4 times, and then the function is x squared plus 3x plus 2. And now we'll just distribute that. So negative 4x squared minus 12x minus 8. And that is 4 times g of x. Negative 4x squared minus 12x minus 8, or negative 4 times g of x. So all we're doing is, in this expression here, replacing this g of x with the g of x function, and then multiplying by negative 4, because the input didn't change. Okay, just a few more examples here. Given the functions f of x equals 3x minus 12, so different functions this time, and g of x equals x squared, find each value. So now we have f of g of x. So we're using the f function here, and the input is the entire g of x function. So let's see what this looks like. So we have f of x is 3x plus 12, but instead of x, we're going to put the entire g of x function, which is x squared. And so this turns out to be 3x squared minus 12. So that is f of g of x here. So g of x, the entire g of x function, was our input for the f of x function. And you see now we're going to flip that around. Now it's g of f of 3. So we're using the g of x function. Its input value is f of 3, which is the f function with 3 as its input value. So you can go about this in two ways. We can evaluate f of 3 first, and then put that inside the g of x function. And let's go ahead and do that because that might be a little easier to wrap our minds around. So let's go down here and do that. So let's just evaluate f of 3 first. F of 3 is 3 times 3 minus 12, because it's the f of x function, 3x minus 12, but we're replacing x with that 3. So that's 9 minus 12, which equals negative 3. So f of 3 is negative 3. Now we're going to plug that in now to the g of x function. G of x is x squared, but instead of x, we're going to put negative 3. And negative 3 squared equals positive 9. G of f of 3 equals positive 9. Okay, last one here. We have g of negative 3 minus f of negative 3. So we're going to evaluate the g function at negative 3, the f function at negative 3, and then we'll subtract them both. So our g of negative 3, that's our g of x function, which is x squared, but instead of x, we'll put negative 3 squared, minus the entire f of negative 3 function, which is 3x minus 12. So let's put some brackets so we make sure we subtract everything. That's 3 times negative 3 minus 12. So we have our g of x function right here, our g of negative 3. that's this right here. Subtracting f of negative 3, which is all this right here. Let's do some evaluating and see what we get. So negative 3 squared, that's 9, minus, then we have over here 3 times negative 3, which is negative 9, minus 12, which is negative 21. So we have 9 minus negative 21. If we change that to plus positive, we end up with 30. So g of negative 3 minus f of negative 3 equals 30. So there you have it, function notation. No real difference between these two types, xy notation and function notation. It's just a different way to show what the input value is for the function so you can find the output at that input.